Welcome to Mentivia. In this module, we're exploring the concept of isotopes and how variations in neutron count reveal deeper insights into atomic structure. Hello, I'm Mark from Mentivia. In this module, we'll explore the fascinating concept of isotopes. You've learned that the number of protons defines an element, but what happens when atoms of the same element have different numbers of neutrons? That's precisely what an isotope is. These variations affect atomic mass and can influence stability and chemical behavior. Understanding isotopes is crucial for a complete picture of atomic structure and helps explain phenomena ranging from nuclear reactions to biological tracing. Let's take a closer look. At their core, isotopes are defined as atoms of the same element that possess a different number of neutrons. This means they share the identical atomic number, as the proton count remains constant, but they will have different mass numbers because the total count of protons and neutrons has changed. Let's use carbon as a prime example to illustrate isotopes. Carbon, by definition, always has 6 protons. This is its atomic number, which uniquely identifies it as carbon. Now, let's look at how its neutron count can vary. Our first example is carbon-12, often written as 12C. This is the most common isotope of carbon. It has 6 protons, as expected for carbon, and it also has 6 neutrons. Adding these together, 6 protons plus 6 neutrons gives us a mass number of 12. Hence, carbon-12. Next, we have carbon-13 or 13C. This isotope still has 6 protons, maintaining its identity as carbon. However, it contains 7 neutrons. This extra neutron increases its mass number to 13. Carbon-13 is a stable, non-radioactive isotope often used in scientific research. Finally, let's look at carbon-14, or 14C. This isotope also has 6 protons, but it has 8 neutrons. This gives it a mass number of 14. Carbon-14 is famously known for being a radioactive isotope, and its predictable decay is what makes carbon dating possible for ancient artifacts. Despite their differences in mass, isotopes of the same element exhibit remarkably similar chemical properties. This is because chemical reactions are primarily governed by the number and arrangement of electrons, which are identical for all isotopes of a given element. The number of protons determines the electron configuration, and since protons are constant, so are the chemical interactions. However, isotopes do differ in their physical properties. The varying number of neutrons directly affects the atom's mass, leading to differences in density, diffusion rates, and even melting or boiling points. Furthermore, some isotopes, like carbon-14, are unstable and radioactive, meaning they undergo radioactive decay unlike their stable counterparts. To summarize, isotopes are atoms of the same element, meaning they have the same number of protons and thus the same atomic number. Their key difference lies in the varying number of neutrons, which leads to different mass numbers. While their chemical properties remain similar, their physical properties, such as mass and stability, can differ significantly. This understanding is fundamental to many scientific fields. Thanks for watching. If your curiosity is still buzzing, hop over to mentivia.com. It's loaded with free videos, e-learnings, and articles to keep your brain happily busy across science, history, and loads more. And hey, don't be a stranger. Subscribe to the channel and stick around. We've got tons of exciting stuff coming your way.